Hi, I am Atanu. In this tutorial video, you learn all short tricks and formula to solve the problem on trains under the times and distance mathematics chapter. First we learn time taken by the train when the train cross a man standing on a platform or cross a pole or cross a bridge, platform or any other stationary object. Let's take this example. Here, this man standing on a platform and this train crossing this man. So how much distance is travel? Now we consider the train travel with constant speed. Let's consider this v meter per second, and length of the train is L. Now you can say that distance traveled by the train while crossing the man would be equal to the length of the train itself. This is because train length is covered as it passes the man. Time taken to cross the man by the train is equal to distance traveled by speed of the train. You can say that it is L by V. This is the formula. Okay. Let's solve one question. Question given that time taken by a 240 meter long train traveling at the speed of 72 km per hour to cross a man standing on platform. So let's draw the picture, line diagram. Suppose this is train and the length is given that 240 meter, right? That is L given, and it's man standing here. Suppose man standing here. If this train cross this man, it has to cover his entire length. So distance travel is equal to length of train, that is 240 meter, and speed of train, this V is equal to 72 km per hour. You have to convert it into the meter per second. So you know that directly you can do that 5 by 18. So meter per second, 20 meter per second. So time taken by the train to cross the man is equal to distance traveled by speed. So what is the distance traveled? 240 meter divided by 20. It will be 12 second is the answer. Same concept like cross the bridge by the train is applicable when the train cross a platform. Look at this picture. Here the train cross this platform. So in this case, the train travel, the total distance is the length of the train plus the length of the platform. Let's consider the length of the platform is P. This is the length of the platform, and length of the train is L, and it's move with the uniform speed V. Okay, so the time taken by the train to cross this platform is the total length traveled by the train, total distance traveled by the train, that is sum of the length of the platform plus the length of the train divided by V, the speed of the train. We get time taken by the train to cross the platform. Clear? Let's understand how to solve another type 1 question where the train cross a bridge. So, look at this picture. Here the train cross the bridge. So to cross the bridge, train has to cross his own length as well as the length of the bridge. Then only it can cross the entire bridge. Now look at the animation very carefully. Suppose here the position of the engine is just left side end of a bridge, and when this engine position become at B, look at this, then the tail part of the train also cross the bridge. Means this entire length of AB has to cover by the train to cross this bridge. So let's consider the length of the bridge is B and length of the train is L meter, B meter, and the constant speed of the train is V meter per second. Clear? So the train crossed the bridge, time taken is equal to distance, total distance travel by the train divided by speed of the train. It will be B plus L by V second. This is the formula. Next, take one example of another type 1 question where the one train is moving or crossing another train which is not moving. So here is the example. This is the first train moving with the velocity v or speed is v, and the second train is not moving, it is standing on the different track. Now if the first train moving or crossing the second train, then look at this. Okay, so it cover the two distance, his own length. Let's first train length is L1 and the second train length is L2. So when it cross, it's cover L1 plus L2 length, the first train cover or move the distance, and its velocity is v. So we apply the same formula. The time taken is total distance travel by this first train and the speed of the first train, that is L1 plus L2 divided by v. Clear? In this way we can solve different kind of the fast type question when one is moving and another object is stationary. Okay. Next we learn the type 2 question where the two trains are moving same direction or the opposite direction. So let's consider this animation. Look at this. The first train, this is the first train, is moving fast and the second train is moving slowly and they cross each other. What happened during the cross? You should have knowledge of the relative velocity. So relative velocity is considered based on the frame of reference. Where is the observer? If the observer, consider the first train is moving v1 velocity or speed and second train is moving v2 speed. Here the observer is here standing on the ground. So this person, what you observe when the train is moving, you observe that this first train is moving very fast and comparatively the second train is moving slowly away from him. Okay. Then now if this person sitting inside this second train and observing the first train through the window, when these both train cross each other, what he will observe? He observe that the first train is just crossing his train or forward the same direction slowly. Okay. And when this person sitting inside this first train and observing the second train, then what you will observe? When the train crossing, you observe that the second train just moving slowly but backward direction. Hope the idea or the concept behind the relative velocity is clear. Thus, here the same observer observing the both train from the ground, and the second case the observer sitting on the second train, and third case the observer sitting inside the first train, and both train are moving, and his feelings of observation due to the different frame of reference where he is sitting or standing, based on that his feelings to the other object of movement is different. That is the relative velocity. Here the length of the first train is L1 and speed of the first train is V1 and length of the second train is V2, and the second train speed is V2 and the length of the second train is L2. So here we consider that V1 greater than V2. So relative velocity is equal to V1 minus V2, and total distance travel due to crossing is equal to total length of the train. So time taken to cross each other is equal to L1 plus L2 by V1 minus V2. Okay. So this is the formula. You must remember this in the case of V1 greater than V2 and the train crossing each other at the same direction at different speed. Now we learn when these two trains moving the opposite direction and they cross each other at the different speed. So now look at this animation. When it cross, what happen? If the observer sitting either first train or the second train, what he will observe? He observed that the other train just crossed his train very fast. Okay, so its speed become higher than the actual speed. Why this is happened? Due to the relative motion. Okay, so let's consider the speed of the first train. The left direction is v1 and the length of this train is L1, and for the second train the speed is, the right direction is v2 and the length is L2. So in this case also the both train means its move total distance L1 plus L2 when they cross the opposite direction. So total distance travel is equal to L1 plus L2, and relative velocity is equal to v1 plus time taken to cross the train each other is equal to total distance travel is L1 plus L2 by relative velocity, that is v1 by v2. This is the formula. Clear? Now look at this animation. Here what you see, the both train are moving with the same velocity. For the few moment you might be experience this kind of scenario. If you sitting inside the first train, what you will observe? The second train, it is not moving. And if you sitting in the second train, what you will observe? The first train? The first train not moving, but actually they are moving. The relative velocity becomes 0. The reason it's become 0. Let's solve one question on train. Here is the question. Train A of the length 141 meter. So this is train A of the length 141 meter. The travel at 90 km per hour. So speed is 90 km per hour. And the train B of 82 meter. So length is 82 meter. The length at speed 72 km it's move. So in this direction 72 km per hour. So they cross each other at opposite direction. Train A move right direction, train B move the left direction, and a passenger inside the train B move the left direction, the same direction it's move. And the speed of the passenger is 2 meter per second. Now look at this animation. Here the train A move right direction, train B move left direction, also the passenger inside the train B move left direction. Now question is, how much time the train A take to cross the passenger? Okay, how you can solve this? So what is the relative velocity in between train A and B? Train A and B is equal to, since they are crossed each other at opposite direction, it will be added. So 90 plus 72, it will be 162. Okay, kilometer per hour, and you have to convert it into the meter per second. So for this we have to multiply 5 by 18. So it will be what? 9 9 into 5, so 45 meter per second. Means the passenger move opposite direction of the train A. Any observer sitting at train A will observe that this passenger, walking passenger of train B, is cross this train A with more speed than the 45 meter per second, and that more speed is actually his walking speed. Is it clear? This is happened due to the relative velocity. So train A cross the passenger walking at train B with speed 45 plus walking speed of the passenger, that is 2. So 47 meter per second. And what length the passenger cross? The passenger cross only the train A, which concept we have learned earlier. When this train A just start crossing the passenger, it only covered its own length, that is 141 meter. Okay, so time taken to cross the passenger by train A will be what? 141 length divided by 47, that is 3 seconds. This is the answer. Means within 3 seconds the train A crossed this passenger. What you see? Just wait. When the train A started crossing the passenger, and now it is end. This is the end of this video. If you want to learn more advanced level, then you can join my online class with affordable fees. Thank you for watching this video.